Here we go. Welcome to the stream. My name's Kent Quirk. I am an engineer and I work for Honeycomb, and I am solving Advent of Code problems in Go, and try to do it with a little bit of engineering. Now, yesterday, today is day 4 of Advent of Code. We have solved days 1, 2, and 3 already. Day 4 yesterday, I ended the stream before finishing it because I was feeling quite a bit of brain fog and not really sort of staring at the problem and not coming up with a solution because I was not working well. So I ended it. I did finish it. Wasn't very hard to finish it once I had a chance to get away and think about it this morning. I'm just going to go over it real quick and show you what I did. So this is the code up on my GitHub, which, by the way, is github.com/kitquirk/AOC2021. Looking at day 3. This day 3A, I tweaked a little bit just to use this count function that I had written, which just extracts the numbers of zeros and ones. And then I wrote a filter function which can be given a predicate, and the predicate will return those items for which the predicate returns true. And so then day 3B was basically a case of getting the different cases correct. So what we do is we calculate the number of zeros and ones, and in the cases of ones greater than zeros, ones equal to zeros, and we're searching for the most common, which is the oxygen solution, or num1s is less than zeros and we're not most common. In those cases, then we filter so as to keep the 1 values. And then similarly, the other cases we filter so as to return the 0 values. And then, so we filter the list. We started with some number, we filter out some of them. If there's only one of them left, then we return that one that is left. If there are none left, then we would panic, but that never happens. And if for some reason we did this and never terminated, or never got down to 1, then we would return a mistake. Anyway, this, when run, gave the right result, and so we finished. So there we are. That was day 3. Let's take a look at what day 4 is. Day 4 is, we're going to find out. Let's read it together. We're already almost a mile below the surface of the ocean, 1.5 kilometers. So deep that you can't see any sunlight. What you can see, however, is a giant squid. Oh, goody. A giant squid wants to play bingo. Bingo is played on a set of boards with a grid of numbers. Numbers are chosen at random. Chosen numbers marked if it appears on a board. If all numbers in any row or column are marked, that board wins. Diagonals don't count in this test. Interesting. Okay. The submarine has a bingo subsystem. Generates a random order for the numbers, a random set of boards, your puzzle input. We're marking the boards with boldface. 24 is drawn, and this guy, third board, wins. The score of the winning board can now be calculated. So we add up all the unmarked numbers on the board. So we need to have a board arranged in rows and columns, or at least be able to calculate rows and columns. This case, the sum is 188. Multiply that sum by the number that was just called on the board 1 to get the final score. So you have to figure out which board will win first. So we're just going to simulate the game and see which one wins, and then do the final score. So this is a little more interesting, both parsing and data representation problem. I am going to take my puzzle input. We have to first parse this. So I'm going to put that in input sample. Oops, no, I'm sorry. Editor. All right, I'm starting with the same basic code blocks that we had before. So there's my input sample. So we have one line. I'm also going to just grab the input itself to avoid having to deal with it later. So this one has a lot of boards. Looks like it's got 120 boards, something like that, and then one long line. So both input systems, both the regular input and the sample input, have a line of numbers, which is the order in which the numbers are drawn, and then a set of boards. And each board is separated by a set of double lines, and then it's a set of numbers separated by spaces. So our parser is going to be a little more just interesting. We think that the board size, well, so one of the things that is possible, well, okay, no, actually, one of the things that's interesting about these puzzles is they never throw a new set of input at you. You always have the same input but have to reinterpret it. So it looks like we are just going to have a 5x5 board. So we could kind of assume that the size of the board is 5x5. So let's figure out how to parse this thing. So we're going to read this, and we're going to read it all. So when we read it all, we get a big array of bytes. And what I think I will do is, if we split on new line, can we split on double new line? If we split on double new line, then we would have one element, which is that, and then a bunch of groups of 5. Let's do that. Okay. So I'm going to rename it to blocks, though, because they're no longer lines. And the draws are we're going to get an array of strings. We're going to basically split the string on white space. So if I recall correctly, the regular expression split in strings.split, bytes.split. Wait, strings.split. But if instead, I was curious about what happens with regex. Sorry, if I find something useful, I will share it with you all. Right now I'm looking in a search facility I have. Why didn't split show up when I did that? Okay, regex splits. So yeah, okay. What we can do is we can say split pattern is regex dot must compile, and we are going to say that anything in the set of comma space new line and tab. So that's basically white spaces plus some extra stuff. And any number of those of at least more than one. So we're going to create that expression as a pattern. And then we're going to do split pat dot split of blocks of 0. And then the number of splits is infinite. So those are the draw values. And just to prove that we got this right, we're going to run it. So let's get a terminal here. And go run main.go. So it is what we expected. A bunch of numbers. Excuse me. And then we need a board object. So we're going to have a type. So each each square can be chosen, and the values are integers starting with the possibility of 0 is one of them. I wonder if they're going to throw in zeros as a free square or something later, but we'll find out. So we're just going to, we're not going to worry about like being too clever here. The square is a struct, and it's going to have a value, integer, and a selected integer, no, bool. And I don't know why I typed integer, it's just an int. And then type board struct is going to have a slice rows So we could do this one of two ways. We could do rows could be a slice of or even a 5 by 5 array. Then we could index row and column. Alternatively, we could simply shove it into a slice of 25 values and then have the thing that looks for an alignment be able to step by 5 when it's checking columns. I'm tempted to just do it as a slice of, or maybe actually an array of 25 integers. Now we could literally create board as a structure. Type board as the array of 25 integers, or 25. It's not, sorry, the 25 squares. Which is fine, except that we might need to expand it later. So I'm going to leave it as this. And then we're going to say, we're going to create a func new board, which can take a string and return uninitialized pointer to board. Board is make. Oh, it's not make. Actually, new board. That will work because it's an array. And then we are, and then we can just, I don't have to initialize it. Oh, no, I am going to initialize it. That's the point. All right, so we're gonna arrange over input, and input is a string. Each value in input is a string, and we need to convert it to an integer. So we're going to xarr is equal to strcont.a to I of s var panic. We shouldn't have a problem with that. And then we can say that board I equals x. Oh, and then this doesn't want to be called rows anymore. It's now squares. There. Oh, and this has to be a square. Value x. Oh, and that has to be renamed. And selected can be left alone. But I'm going to rename this to capital B value. And this to selected. And then return board. Okay, so we have created a new board. And we can initialize it with the parsed result of this split pad. You know what I'm going to do? I'm going to create this as, instead of doing the 25 thing, it will be initialized to nil, but I'm going to write a little function to essentially do this part. But func parse and I'm going to move the regex into this. So we create the split pattern, we split the input. String slice for underscore comma s colon equal range ss. Oh, we need And then slice of int 0. Actually, I don't even need to do that. I can just var result slice of int, because when you append result equals append result, if result is nil, then the append will create a new one for you. So x. So that, and then return result, and it's not going to be happy about that because it has to return slice of int. Okay, now I can see board is new board, board dot squares. Values is parse input this is no longer a slice of string, it's a string. And then for underscore comma v in range values, we're going to board dot squares equal append board squares comma v. If line of board dot squares oh wait, did I, this should be, might not let me because I've got a syntax error right now. Let's see. Update, okay. Not equal to 25. Panic long length return board. Okay, so So now we're going to take the range of blocks, but we can start with block 1. So we're going to do blocks of starting at 1. And then we're going to say board, new board, block, boards, bar boards, slice of board, boards equal append boards board. Oh, boards needs to be a slice of pointer's board. So I'm going to write so there's new board. We're going to give board a toString method so that it conforms to stringer. So we're going to say func b star board. Actually, we'll just do b board. toString, right? No, it's just string, right? Format.stringer is an interface which just has a string function. Okay. So string function is what am I doing? Print that, and if I %5 is 4, make that print. Oh, sorry, I forgot what I'm doing here. This is, I don't want format that prints in here. I want to, I'm going to build up a string. S is a string builder. Strings.builder. And then s dot write oh sprintf. We'll just do sprintf. And so our format is going to be %d space and b that squares of I, and then we can get rid of this. And okay, let's just run this real quick and see what we get. Oh, except I want input sample dot text. Okay, there are no more format. Meter squares of I is correct value. And I think what I can do is I can go %. of a Boolean. Well, let's just print this first, and then we'll figure out how we print the occupied ones after. Oh. Doesn't like in A doesn't like a blank. So that's completely plausible that we might have an extra blank in there because of the way I did the new lines. So let's just say continue, save that. We'll try this now. All right. Oh, and I printed 3 pointers. I don't really want to print 3 pointers. I want to print 3 boards. So let's just see if I did a B star here, if this would work. I thought it would type convert it, but maybe it won't. Huh. There we go. Fascinating. Okay, so I have printing each board, but here I need to print the value. That's supposed to be squares of I dot value, which should be an int. It's printing string. That is not a stringer function. Okay, my bad. Oh, return s dot string. I'm probably, I mean, the string builder is useful, but maybe, let me see. I'm going to do this again, comment this out for a second, try rerunning it and see if I get what I expected. There we go. Okay, and then we are going to have the string function add one more new line to this. And I also feel like it should be, right, rune, and these should be single quotes. And write one more rune, and then do the string, and then try this again. Why is the first, okay. Oh. Yeah, it's writing an array. So let's get rid of this and comment this. Do it one more time. Ooh. There we go. Now if I go back and change my string function to take just a plain old board, does it still do what I want it to do? Yes, it does. That's what I wanted. Okay. I also think I'm going to put this at the top rather than the bottom. There we are. Oh. I'm just making that so that it's a little cleaner. There we go. Now it lines up. And we are going to say if oh, all right. Now we will get an asterisk in front of selected squares. Okay, I feel pretty good about that. Now we can actually play the game. So we need a function, we need a member function on board, a method, func b star board. This is going to modify board, so we have to make it a function, a pointer. Select value int, and then we're going to return a bool just in case it becomes important, which is the value is whether or not we found it in a list. So for I in the range b dot squares, let's do I comma b just to save ourselves a little grief. If b equals value double equals value b dot squares I dot selected equal true. Return true. Return false. Okay, so we can call a select function now, and the there we go. So the other function we need to write on board is the check for win. Check for win. Bool. So we're going to go All right, so now we have to check whether with the selected value in our win conditions. So we could make a list of all the possible win conditions and then just iterate through those. It might be a little easier, actually. Just try writing this down for a second. Win conditions equal. And these are indices. So 0, 1, 2, 3, 4 is a win condition. So we have 10 win conditions. 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9. Oops. 10, 11, 12, 13, 14. 15, 16, 17, 18, 20, 22, 23, 4. Okay, those are all the and then we basically need 0, 5, 10, 15, 20. Oh, yeah, that was maybe not the right way to do that. One, 6, 11, 16, 21, 2, 7, 17, 12, 17, 22, 3, 8, 13, 15, 3, and 4, 9, 14, 19, 24. There we go. Those are all my win conditions. So now check for win. I can do for WC global range win conditions for index equal range WC. If we're going to default file to true, and if b dot squares dot of ix dot selected false, we're going to say found equal false, and we can break because we don't have to check anymore. But if we get to here, if found, return true. Return false. So we had to loop over all the win conditions. Then for each win condition, we had to loop over all the squares for its selected. And we assume with it we found it. And if at any time we find that there was not a selected cell, then we found is false, so we can break and go up to our win condition. If we never broke, then found will still be true, and we will immediately return true. Otherwise, we're going to return false. So this will return whether one board is a win. And then the last thing we have to do is wait, if a board is a win, what was our instruction say? Oh, we have to calculate the score. B star board, that can be a B board, score, and it's multiplied by the last number called. And it returns an int, so we say for I, comma, n colon equals range b dot squares if b dot squares I dot selected not equal to select is false, then we sum plus equals b dot squares of I dot value I dot value return sum times last number, sum is 0, yeah, we'll just do it this way since I already wrote that code. All right, we will satisfy the linter. And then I'm deciding that I think since the thing uses marked rather than selected, I'm going to rename this symbol to marked. Okay, so I can simplify this. Since it's already declared up here, there can only be one thing, so that's good. And then this, same thing here, instead of marked as false, not marked. All right. So I have my draws. Day, let's see, so this is 04A, and we're gonna move this code well, actually, I think instead of that, since I'll probably reuse these two data structures, it means this thing here. So we've got the boards and the draws. So we'll say draws, slice of int, boards, slice of board, pointer to board, right? And it's going to return an int. All right. So now day 4a takes a list of boards and it says for I only equal range draws underscore, I don't need the index here, underscore draw range draws for B range boards B dot mark matching draw if B dot check for win return B dot score. Oh. So then let's call day 4a. Okay, that's it. There are no errors on the side, so let's try and see if this works. 4512. 4512. So that is correct for our sample data. So let's do it for the real thing. I love it when something runs on the first try. 25410 is what it claims. The answer is 25410. It is the right answer. Yay. Okay. So just to prove it, I typed that into the terminal, into the browser, and we have the right answer. So we're going to continue to part 2. On the other hand, let the Wookiee win. We weren't sure how many a giant could play at once, so rather than wasting time counting its arms, which, as I recall, with squids there are 10, safe thing to do is figure out which board will win last and choose that one. Okay. Figure out which board will win last. Once it wins, what will its final score be? This one should be pretty easy. It's a minor variation on day 4A. Instead of quitting as soon as we find the winner, we can just stop. See, this is where we're glad that we made board in being a type, because now we can just say 1 is a bool, and we'll mark 1 and we won't consider the ones that have 1 after they win. So if we check winner, sorry, here we are, day 4B. So B, check for win. Wait. We have a slice of boards. I think what I want to do is just remove let's remove the board from this consideration. So So for every draw, we go over all the boards that are in the range. If we win, we have to remove. Okay, so now I need the index. Because what I'm going to do is I'm going to remove the winning board from the list. I'm also, since I'm going to remove the board from the list, I don't need the 1 flag. I think it's easier to keep track of the boards that haven't won. So we can say boards now is equal to so say we had boards as something like, 1, 2, 3, 4, and board, I'm actually going to do this with 0, and board 3 wins. Then we're going to say boards equal boards of up to I here's what we're going to do. We're going to swap the winner for the last one and then shrink boards by 1. So we're going to do boards of I, boards of length of boards minus 1 is So we're going to swap those two values. And then boards becomes boards up to length of boards. So we're going to take the one that won, we're going to swap it with the last one, and then we're going to move in by one. It makes it's the easiest way to delete an item from a list without any conditionals and things like that. So that works. Wait. If length of boards is 1, we can break. I always put a semicolon on the end of it, but it just goes away. Okay, so we're done. Oh, but this is, we need to break outer. So we're going to put, say break outer, because we need to break both loops. All right, so now we have one, and return b dot score. Oh, instead of break outer, yes, we can return because we're done. We just need to calculate the score. Interesting typo. Oh, I'm so sorry. I've been not showing you the editor. Damn it. I hate when I do that. It's what comes from not being able to see Twitch while I'm playing. People came in the chat room, probably saw nothing and left. I'm sorry about that. Anyway, so it goes. Here you go. Now we're back to so we're iterating over draws. We have a range of boards. Same thing as we're checking for matching. Then we check for win. If the board won and it's the last board, then we return the score. Otherwise, we remove that board from the list by swapping it with the last one and then shrinking the list by 1. Because we don't care what order we evaluate these in. And our other big thing is that after we've done, we can't really run both because we're modifying all the arrays of boards, and I don't feel like writing a reset function. So we're just going to run B instead. We'll run one or the other one, but not both. And so this one should return 1924. And instead it crashed. Well, first problem was that it should have been input sample. Let's do that. And we'll check on the input sample to see what we got wrong. 2192, so we did it wrong. So what did we do wrong? I just want to see. It should have finished after 13, but it didn't. Wait. Where's 13? There's this. Okay. Oh, it would have been the next number. That's interesting. So so what happened? After 16, it thinks. Oh. Yeah. Is that right? All right, we're just gonna do this and let it print file junk. Oh, 7. I don't like that because they're 2-digit numbers and it's in front of the number. I'm just going to change my string function so it's a little easier to work with. I'm going to put this here, put it after the number, and then I messed up. There. So it is a win for that with 16, but there are 2 boards left. So what did I do wrong here? Oh. Huh. No, that's not right. Oh. Multiple boards win in one turn. We have a problem. My delete's not good. You shouldn't. We basically sort of sawed off the branch we were standing on. So let's do this better then. Instead of removing the board to just one, so I want to count the number of winners that I have. So what I'm going to do then is I say, on each draw, I say, winners, non-wins, all right, so I'm going to go back here. I'm going to give this a win flag again. Try that. And we are going to say, first of all, mark matching if b dot win it's already run. We don't bother to check matching. Check for win. If b dot win return true. So now it's maintaining b dot win for us. And here we can say if we check for the win, if we check for win and didn't win, non-wins plus plus, and if non-wins is 1, if non-wins is 0, then we just fit 1 on that one because we're returning now. We're going to say return b dot we check for the win. We want to track the score. Score equals score draw. Something's wrong. What have I done wrong? I never used I. Okay, I didn't need it. And it doesn't like something. Oh, Day04 is unused. That's okay. Let's try this again. See if we get. Oh, that's not good. Oh, that's not right either. Because the score for each of the boards, I only want the one that was. This is annoying. Okay. If not, b dot win. So we won't bother to do anything. See if that does it. There we go. Okay. Now we can go back to the input. And hopefully this time our final score is 2730. And we got it. Yay, okay. So, yep, 2730 is the correct answer for part 2. So we have done it. Today is done. Thank you for watching. I apologize for having spent too much time staring at a browser, leaving you staring at a browser, but so it goes. So, I hope you all have a great day, and we'll see you tomorrow. Bye.